So this is the general form of the LC oscillator, and here we have used op-amp in the place of a basic amplifier circuit, and this is going to be the feedback circuit. This is going to be the feedback circuit, but we don't know what is op-amp, but we need not to know much about the op-amp, only we are concerned about the output of the op-amp. And why we are using op-amp fields? We can design, in the previous days, the circuits, LC oscillator circuits are designed using transistor amplifier and FET amplifier. Nowadays, latest technologies are using op-amp as the basic amplifier, op-amp as the basic. What is the advantage of using FET and op-amp in the place of transistor as an amplifier? The main advantage is that input impedance of FET and op-amp are going to be very high. They are in the range of mega ohms in the FET, and here the input impedance is going to be infinity for an ideal op-amp. That we have to learn. And there is one other characteristic of the op-amp is that the input impedance of the op-amp is much high such that no part of the current will go into the op-amp. No part of the current will not go into the current. So here if you apply any feedback, generally op-amps will have feedback circuit also. Here we don't use that. So if you apply a feedback, that current will enter into this, but here the current will not enter into the op-amp. So this is called IB plus or IB minus. So these two currents are going to be zero. These two currents are going to be zero. That is the only point you have to remember. That is, no part of the current will enter into the op-amp. Next, and this is the equivalent of this circuit, and we are going to analyze our general equation, our general analysis of the oscillator by using this circuit. Now here we can observe this circuit. Let me explain something about this circuit. What is the circuit? Here this op-amp is having three terminals. This is called inverting terminal because negative sign is there, inverting terminal. This is called non-inverting terminal and it is grounded. And here this is the output terminal, and the gain of the op-amp is going to be AV, and because the input is given to the input is given to the first terminal, that is inverting terminal, the gain is going to be negative gain. So what is my output is going to be? Minus V0. My output is going to be minus V0. That we have to remember. Next thing. Next thing. Here, whatever current is flowing in this Z3, Z1 and Z2 branches, you just observe. Z1, Z2, Z3 are the impedances. Z1, Z2, Z3 are the impedances. Why we are going to use impedance instead of resistance? Resistance ante R anedi resistance ani use chestam. Eppudu only resistorlu unna circuits. But this resistance is not at all dependent on the frequency. But whereas in some circuits we are going to use the capacitor as well as inductor as the elements of the circuit. They are frequency dependent components. So to represent the resistance of that circuit, we are going to use a term which is called impedance. And this impedance is represented with Z, and this Z is going to be R plus JX, where JX is going to be the reactance, and this reactance plus resistance is going to give the impedance. Here The resistance is the real part and reactance is the imaginary part. So this is the complex term when we are going to consider the impedance. And also, if my given element is a capacitor, then what is my Jx is going to be? My Jx, my X, so I can represent this. If it is a capacitor, I can represent this with Xc. So what is this Xc is going to be? Xc is going to be minus 1 by omega c. Next, if it is an inductor, then my impedance is going to be JXL. So what is my XL is going to be? My XL is going to be omega L. You just remember these points. Now, let us explain something here. Here, when the output is concerned, here whatever current is flowing through this will not enter any part of the current in this. Here shown is I equal to 0. Even though we are connecting a wire from this point to this point also, no current will enter this. So whatever current will come from this point, the same current will go through this Z1 also. So in which way they are connected, we can say that whatever current is flowing in this, the same current will flow in this also. So these two can be considered as the series elements. Z3 and Z1 are in series. And for this combination, this Z2 is going to be parallel. And we can observe one thing here. Terminal 3 is grounded and this is also grounded. So that we have to consider. Now what is the equivalent of this op amp is going to be? So this op amp is represented with, because it is a negative gain. So what is gain actually? What is gain? V0 by Vin is equal to gain. Voltage gain AV. Here. Now, what is V0? V0 is going to be AV into Vn. Actually, we have to write Vn here, but what we wrote here, V13. What this V13 represents? V13 represents the voltage across first and third terminals. So which is nothing but input voltage, which is nothing but the voltage exists here is nothing but input voltage. So I can write instead of AV, V input, I can write AV, V13. So he wrote that. Next, and this is R0 is the output impedance of the circuit. It is an output impedance of the circuit, output resistance of the circuit. And here, this is considered as the total Z3, Z1 and Z2 are considered as the load impedance ZL. It is considered as load impedance ZL. So, load impedance ZL is going to be, I am considering only with single letter, but this single letter is going to have the series combination of this that is parallel with the other element Z2. So, Z3 plus Z1 which is parallel to the Z2 will give my ZL. So, what is the expansion of this? ZL is going to be series parallel combination formula em cheppanu, product of the elements divided by sum of the elements. So what is the product of the elements? Z3 plus Z1 into Z2 divided by Z1 plus Z2 plus Z3. You just keep it in your mind. so that I can continue my analysis. I will rub this and we go for the analysis of this general form of LC oscillator. Now, what we know that now we consider Z3, Z1 and Z2, and this is the equivalent circuit we are going to consider. Now, let me write the total thing into ZL and write the circuit. So, what will be my circuit? My circuit is going to be minus, plus and R0 and ZL. This is going to be my ZL and this is going to be my RL and this is going to be AV-V13. Now I want to find what is the, let me write like this because you may confuse with C and L. So ZL. And what is my gain A is going to be? It is the gain of the amplifier, without feedback. That means without feedback. అంటే దాని అర్థం ఏంటి? అంతకుముందు మనం నెగటివ్ ఫీడ్బ్యాక్లో మనం నేర్చుకున్నాం ఏమనంటే, what is the meaning of gain of the amplifier without feedback means we are not considering the feedback circuit but the loading effect of the feedback circuit is going to be considered, and we don't have the feedback element in the circuit which is in between input and output. So here my feedback gain, that means gain of the op amp without feedback is going to be A, and this A is going to be minus AV into ZL by ZL plus R0. How I got this? Let me explain this. ఇది ఎలా వచ్చింది? So, what is the output across ZL? V0. Ante kada. What is the voltage drop across ZL? That is nothing but V0. So, what is the voltage V0 is going to be? V0 is equal to this voltage, that is minus AV into V13, that can be written as Vin, into ZL by ZL plus, that means the impedance at this branch divided by total impedance. So what is my V0 by Vin? V0 by Vin is nothing but A, that is nothing but minus AV ZL by ZL plus R0. Is it clear? Now this is my A. What I have to calculate now? I have to calculate minus A beta. So to calculate minus A beta, I have to calculate beta also. What is my beta? What is my beta? Beta is the VF by V0. And here VF is the output of the feedback network and V0 is the input of the feedback network. So if I consider the feedback network here, so which voltage is going to the input? Which voltage is going to the input? If you consider here this part, the drop across this is going to be the input of this amplifier. This is nothing but VF. This is nothing but VF. And what is V0? V0 is the voltage across this. So, what is my VF by V0 is going to be? What is the drop across this? this drop across this is going to be, let it be VF. VF is equal to V0 into Z1 by Z1 plus Z3. Because these two are in series, so drop across this will be given by the total voltage into impedance of this branch by total impedance, voltage division law. So VF by V0 is going to be VF by V0, which is nothing but beta. Here we have to consider one thing, that we are not taking V0 but we are taking minus V0. We are taking minus V0. So if I put minus V0, VF by V0 is going to be minus V0 and minus beta is going to be this. If I take this minus to this side, then it will be Z1 by Z1 plus Z. So if I multiply these two, what is my minus A beta? That we are going to calculate now. Let me rub this. So what is my minus A beta, which is nothing but minus of A into beta. What is my gain became? My gain is minus AB into ZL by ZL plus R0. Isn't it? Next, what is my beta? My beta is going to be minus Z1 by Z1 plus Z3. So if I multiply minus into minus plus, and one minus will be left. So the minus into multiplication of this. So what is my ZL is going to be? Already we have seen what is ZL. Load impedance is going to be the series combination Z1 plus Z3, which is in parallel with Z2. So what I can write? This is nothing but Z2 into Z1 plus Z3 divided by Z1 plus Z2 plus Z3 divided by this I am writing. Again Z2 into Z1 plus Z3 divided by Z1 plus Z2 plus Z3 plus R0. This is about this. Next, into minus Z1 by Z1 plus minus is gone, Z1 plus Z1. So here what I wrote, I have to cancel, only one minus is left, that I have to write. Now so shall I cancel? I will simplify this. So this will become minus AB into Z2 into Z1 plus Z3 divided by, if I take the LCM, I can cancel these two. So if I take the LCM, what it will become? Z2 into Z1 plus Z3 plus R0 into Z1 plus Z2 plus Z3. This way. Into Z1 by Z1 plus Z3. I will get this. So I can cancel this. And what I am left with, this quantity by this quantity I am left with. Let me write here very clearly. Now I will rub this. So what is this? I am getting minus A beta. I am trying to get minus A beta. So what is my minus A beta is going to be minus of AV into Z2 by, Z2 into Z1 is also left. Z1 here, Z1 and Z2 and Z1 are there, divided by R0 into Z1 plus Z2 plus Z3 plus Z2 into Z1 plus Z. This I am going to get. Now, so what we are considering? We are considering Z1, Z2 and Z3 as impedances. We are considering Z1, Z2 and Z3 are impedances. Suppose if I assume that these three are purely reactive elements. That means the impedance which is not having any real part. What is the meaning of reactive element? Reactive element means Z is equal to R plus Jx is there. So I don't have the resistance. So what I will get? Purely imaginary part I will get. Jx only I will get. So let us suppose, assume that Z1 is equal to Jx1, Z2 is equal to Jx2, Z3 is equal to Jx3, and there is no resistive part. So these three will be purely reactive elements. So these three will be either capacitors or inductors and both mixed. So now we are going to consider Z1 and Z3 and Z2 as sometimes we will consider them as capacitors, two capacitors and one inductor, and two inductors and one capacitor. So if you consider them in this way, so we will get two types of LC oscillators. One is Colpitt's oscillator and the other is Hartley oscillator that we are going to see now. Now we are going to substitute, instead of Z2 we are going to substitute Jx2. That we are going to do. And which type of oscillator will come? We will see next. So I have this. So instead of this is going to be minus AV into Jx2 into Jx1 divided by R0 into Jx1 plus Jx2 plus Jx3 plus Jx2 into Jx1 plus Jx3. So I have taken these values. Now J into J, J square. What is J square? Minus 1. Minus into minus, plus. So this will be AV into plus AV into x1, x2. I will get it in the numerator. Next, if I take J as common, then what I will get? J R0 into x1 plus x2 plus x3. Next, plus if I take J as common, J into Jx2 into J I will get, and x1 plus x3 I will get. So what is J into J? J square. So J square is equal to minus 1. So I can remove this and I can put minus here. So minus x2 into x1 plus x3 I will get. Now this is the equation which is having a real part and an imaginary part. A real part and an imaginary part. Now, I will rub this. So, I have to split it into real part and imaginary part. So, what I have to do? I have to separate the imaginary part and real part. For that, what I have to do? My imaginary is in the denominator. So, I will multiply. Otherwise, so minus a beta is equal to this quantity. Here we can't identify the real part and imaginary part separately. So when I can identify, when my j is on the top, then I can identify the real part and imaginary part. For that, what I have to do? If I simply multiply with the j will come here, j will go, j into j square, but here again j will come. కాబట్టి ఇది కుదరదు. సో ఏం చేయాలి నేను? డినామినేటర్ క్వాంటిటీని మధ్యలో ప్లస్ పెట్టి ఆ క్వాంటిటీతో న్యూమరేటర్ని డినామినేటర్ని మల్టిప్లై చేయాలి కాంజుగేట్ తోటి. సో వాట్ ఈజ్ మై మైనస్ ఏ బీటా ఈజ్ గోయింగ్ టు బి మల్టిప్లైయింగ్ న్యూమరేటర్ అండ్ డినామినేటర్ with a quantity which is having plus in denominator with plus. So conjugate of the denominator. So em vastadi naku jr0 into x1 plus x2 plus x3 plus x2 into x1 plus x3. So this is the quantity with which I am multiplying numerator as well as the denominator. So if I multiply this with the denominator, jr0 into x1 plus x2 plus x3 minus x2 into x1 plus x3 into the same thing with plus. So jr0 x1 plus x2 plus x3 plus x2 into x1 plus x3. So this is a minus b into a plus b. So what will be the formula? A square minus b square. That I am going to get. So now the multiplication will give j r0 into x1 plus x2 plus x3 into av x1 x2 plus av x1 x2 av x1 x2 into x2. So I can write x2 square, x2 into x2 into x1 plus x2 divided by what I will get? A square minus b square. What is my a square? J square and this whole square. So what is j square? Minus 1 into r0 square into x1 plus x2 plus x3 whole square. Next, minus b square. That is minus x2 square into x1 plus x3 whole square. So this is the equation I get. So what is my imaginary part then? My imaginary part will be, so to find this, the phase shift of the loop should be equal to 0. When the phase shift is going to be 0? When j quantity, imaginary quantity is going to be 0. So this quantity is going to be 0. This quantity is going to be 0. So my imaginary part is going to be 0. So R0 into x1 plus x2 plus x3 divided by the total thing. Let it be y. Let the p అనుకోండి. It should be equal to 0. ఈ మొత్తాన్ని p అనుకోండి. It should be equal to 0. So now this total part, I missed this, you have to consider this also. This is my imaginary part and this is my real part. So while we are dealing with the real part, j unna quantity idi by denominator idantha imaginary part avutadi. J leni part divided by the denominator idi real part avutadi. So ఇప్పుడు R0 x1 plus x2 plus x3 into ఇది కూడా ఉంది. సో AB into x1 x2. డినామినేటర్ మొత్తం p అనుకున్నాం, మొత్తం రాయకుండా. సో వాట్ మై ఇమాజినరీ పార్ట్ షుడ్ బి 0. ఇది 0 అయినప్పుడు ఈ R0 0 into R0 0. ఈ p 0 into p. Sorry, R0 0 by R0. సో అవతలకి వెళ్తే ఏమవుతుంది? ఇది 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 మొత్తం కూడా ఈ రెండు డివైడ్ చేస్తాయి, ఇది మల్టిప్లై చేస్తుంది. 0 into something will give 0. So what I am left with? So what is my left part is going to be x1 plus x2 plus x3 is equal to 0 into p, total denominator p అనుకున్నాను, divided by R0 into EV x1 x2. So 0 into something will give 0. So my total value becomes 0. So what is the equation I got here? x1 plus x2 plus x3 is equal to 0. So this is the equation I got when I made imaginary part equal to 0. ఇది ఓ పక్కన, ఇది is equation number 1, దీని ఓ పక్కన. Now this is nothing but, now what is my real part is going to, what is my real part? Let me have this R0 square into x1 plus x2 plus x3 whole square. ఇది నా రియల్ పార్ట్ ఇప్పుడు ఇంపార్టెంట్. సో రియల్ పార్ట్ని రాస్తాను. ఇమాజినరీ పార్ట్ ఈజ్ ఈక్వల్ టు 0 చేయబట్టి నాకు ఒక ఈక్వేషన్ వచ్చింది. Now what am I taking? I am taking the real part. So what is my real part? Real part is going to be AB into x1 x2 square into x1 plus x3 divided by minus R0 square into x1 plus x2 plus x3 whole square minus x2 square into x1 plus x3 whole square. This is my real part. So what I got while I am making the imaginary part 0, what I got, x1 plus x2 plus x3 is equal to 0. So this total thing is going to be 0. So AB into x1 x2 square x1 plus x3 divided by 0 into something 0 and minus, so I can remove this 0, x2 square into x1 plus x3 whole square. So x1, x3 and square will be cancelled. x2 square and x2 square are going to be cancelled out. Now, what I am left with? So, what is the real part? Real part is nothing but minus a beta. So, minus a beta. It is nothing but ab into x1 divided by minus x1 plus x3. Now, what I have x1 plus x2 plus x3 is equal to 0 kada. ఇప్పుడు x1 x3 ఏమవుద్ది? x1 plus x3 is going to be minus x2. దాని బదులు minus x2 రాసుకోవచ్చా? సో రాసుకుంటే ఏమవుతుంది? ab x1 by minus x2. So that is going to be minus into minus plus. So this is ab into x1 by x2. Now, first of all, minus a beta is nothing but your gain, and it should be equal to plus 1. It should be equal to plus 1 according to the Bargh-Hassan criteria. So, ఇది plus 1 అవ్వాలి అని అంటే ఈ రెండు కూడా ఒకే క్వాంటిటీ అవ్వాలి. ఒకే క్వాంటిటీ మీన్స్ ఇఫ్ ఇట్ ఈజ్ అన్ ఇండక్టర్, ఇట్ ఆల్సో షుడ్ బి అన్ ఇండక్టర్. ఎందుకని? ఇఫ్ ఇట్ ఈజ్ ఎ కెపాసిటర్, ఇట్ ఈజ్ ఆల్సో షుడ్ బి కెపాసిటర్. దెన్ ఓన్లీ మై టోటల్ క్వాంటిటీ విల్ బి పాజిటివ్. పాజిటివ్ ఎందుకు? ఒకవేళ ఒకటి ఇండక్టర్ ఒకటి కెపాసిటర్ వేసాను అనుకోండి, వాట్ ఈజ్ x1 j, ఇది ఇండక్టర్ అనుకుంటే j ఒమేగా L1, ఇది కనుక కెపాసిటర్ అనుకుంటే మైనస్ j బై ఒమేగా C. సో j will be cancelled out, omega square LC, but one negative sign I am getting. So I should not get the negative sign because I am having a positive one. I should have a positive quantity. So to make this total value positive, x1 and x2 should be either inductors or capacitors. So they should be same elements. So with this, I am going to get two types of oscillators. That means with Z1 and Z2 inductors, Z1 and Z2 inductors and Z3 as the capacitor, and Z1, Z2 both are capacitors and Z3 inductor. So if Z1 and Z2 are both are capacitors and Z3 is the inductor, it is Colpitt's oscillator. LC oscillator lone it will become Colpitt's oscillator. మీరు బండగుర్తోటి పెట్టుకోండి. Colpitt's లో C ఉంది కాబట్టి రెండు Cలు వస్తాయి, రెండు కెపాసిటర్లు వస్తాయి. సో Z1 and Z2 will be capacitors, the other will be inductor. So the next thing is the Hartley oscillator. So what is the Hartley oscillator? Z1 and Z2 will be inductors and Z3 will be the capacitor. So we will have two types of LC oscillators we can get by using this general analyzation of the LC oscillator circuit. So we can get two types of circuit. So this is about gain of the oscillator, and we know now we have to derive what is the frequency of the two oscillators. ఇప్పుడు రెండు ఆసిలేటర్స్ వస్తాయని చెప్పుకున్నాం కదా, ఆ రెండు ఆసిలేటర్స్ కి వచ్చే ఫ్రీక్వెన్సీస్ ఏంటి, that we are going to derive. So when we will get the frequency? If we make the imaginary part equal to 0, then we will get the frequency. So what is my imaginary part? 0 means x1 plus x2 plus x3 is equal to 0. When I made imaginary part 0, I got this equation. So if I use this equation, what I will get? I will rub and explain. Colpitt's oscillator, what is my frequency? For Colpitt's oscillator, X1 and Z1 and Z2 must be capacitors. Ade kada anukundam. So X1 and X2 must be capacitive reactances. So minus J by omega C1 minus J by omega C2, and X3 is an inductor. So it is plus J omega L3, and this should be equal to 0. So if I take J common, they will be cancelled out. So what I will get? Minus J is gone. Omega L3 is equal to 1 by omega C1 plus 1 by omega C2. If I take 1 by omega as common, 1 by C1 plus 1 by C2. So omega square is equal to 1 by L3 into 1 by C1 plus 1 by C2 I will get. So what is this 1 by C1 plus 1 by C2 will show? This is nothing but 1 by L3 into C1 plus C2 by C1 C2. If I take it to the denominator, this is going to be L3 into C1 C2 by C1 plus C2, which is nothing but parallel combination formula. Parallel combination formula. So already we have learned that R1, R2 అనే రెండు resistors parallel లో ఉంటే దాని ఫార్ములా ఏం వేసుకున్నాం మనం? R1 R2 by R1 plus R2. ఇది resistors parallel గా ఉంటే వేసే ఫార్ములా. But what we got here is capacitors అలా వచ్చింది. But even though we are getting parallel formula of resistors, capacitors కి ఆ ఫార్ములా ఎప్పుడు యూజ్ చేస్తామంటే when capacitors are in series. రెండు capacitors ని సిరీస్ లో కనుక పెట్టి క్యాలిక్యులేట్ చేయమంటే then we have to use this formula. అర్థమైందా? So what is my omega square? Omega square. So I can change it as C equivalent అని రాసుకుంటాను. ఈ మొత్తం క్వాంటిటీని ఏమని రాసుకుంటాను? C equivalent అని రాస్తాను. రాసినప్పుడు ఏమవుతుంది? Omega square is going to be 1 by L3 into C equivalent, where C equivalent is equal to C1 C2 by C1 plus C2. Next, what is omega? Omega is going to be 1 by root of L3 into C equivalent. What is frequency? 2 pi f is equal to omega. So this is L3 into C equivalent. So f is equal to 1 by 2 pi root of L3 C equivalent. This is the formula for frequency of a Colpitt's oscillator. A Colpitt's oscillator. Next, now we have to derive a formula for Hartley oscillator. So what is the formula for Hartley oscillator? Hartley oscillator frequency. So for this also I have to use the equation x1 plus x2 plus x3 is equal to 0. Now what we have learned for Colpitt's oscillator, Z1, Z2 are capacitors. So for Hartley oscillator, Z1, Z2 should be inductors. So j omega L1 plus j omega L2 minus j by omega C3 is equal to 0. So if I take J common, J will go. If I take omega as common, omega L1 plus L2 is equal to, when this goes outside, right side, it will be this. When omega comes here, omega square is equal to 1 by C3 into L1 plus L2. When inductors are in series, then they will be simply addition of those inductances. So L1, L2 series లో ఉన్నప్పుడు దాన్ని అడిషన్ చేస్తాం. రెసిస్టర్స్ ఎలా చేస్తామో అలాగే చేస్తాం. కానీ కెపాసిటర్స్ సిరీస్లో ఉన్నప్పుడు రెసిస్టర్స్ ప్యారలల్లో ఉన్నప్పుడు ఎలా చేస్తామో ఆ ఫార్ములా యూస్ చేసి చేస్తామో అది గుర్తుపెట్టుకోండి. సో ఐ విల్ టేక్ ఇట్ యాజ్ L ఈక్వివలెంట్. సో L ఈక్వివలెంట్ and L equivalent is equal to L1 plus L2. Now, so what is my omega? Omega will be root of C3 into L equivalent. What is my F? F is going to be 1 by 2 pi root of C3 into L equivalent, which is the formula for the frequency of an Hartley oscillator. So this is the general equation derivation for the LC oscillator, and this is the equation. Now I forgot one thing to explain to you, how an LC circuit can be used as an oscillator. That I have to explain it in the first step itself, but I forgot it to explain. Let me explain it. Now, we come across a circuit which is called a tuner or tank circuit while we are dealing with radio communications. Radio communications లో మనకు ఒక సర్క్యూట్ వస్తుంది. ఆ సర్క్యూట్ని ట్యూనర్ సర్క్యూట్ ఆర్ ట్యాంక్ సర్క్యూట్ అంటారు. సో దిస్ ఈస్ ద సర్క్యూట్ ఆఫ్ దట్. ఇట్ ఈస్ ఏ ట్యూనర్ ఆర్ ట్యాంక్ సర్క్యూట్. This is nothing but LC oscillator. This is nothing but LC oscillator. How this will become oscillator, that we are going to see. And you know that capacitor and inductor. And you know that capacitor and inductor are both energy storing devices. They are both energy storing. Now we are going to learn the tuner or tank circuit, which is going to be used in radio communications, which is a frequency selectivity circuit. That means whatever frequency you want to tune, that frequency can be tuned by using this tuner or tank circuit. And this is nothing but a LC oscillator circuit. How this will behave like a LC oscillator circuit, that we are going to see now. Suppose a capacitor is to differentiate between the battery and the capacitor, I use this, but generally capacitor will be two equal lines only. So to differentiate, I use this symbol. Now if a battery is connected across a capacitor, so this battery will charge the, if it is of V volts, this battery will charge the capacitor also with a charge of V volts. Capacitor. Here the top plate will be having plus positive charge, and the bottom plate will be having negative charge. So this is a parallel plate capacitor. When a capacitor is charged with a charge of some volts and it is connected in this mode, what happens? That we have to see. Now we know that the current will start flowing. So if my current is start flowing, what will happen? my current will enter through the inductor, and this inductor is nothing but a current carrying conductor. So when some current flows through this inductor, it will produce some magnetic field. It will produce some magnetic field, and that magnetic field is responsible for storing the energy in it. So the energy stored in this will be half Li square, and the energy stored in the capacitor is half Cv square. That is the different thing. We don't need here. Now, what is the principle of this inductor is going to be? That means if there is any change in the voltage or in current, then that will change the flux linkages. So if there is a rate of change of flux linkage, then EMF will be produced, and that EMF is called the back EMF, because that EMF will oppose the original EMF, which is going to create this magnetic field. So when the current is flowing through this, then gradually my charge is going to empty here. First 1 plus will go, that 1 minus and 1 plus will go. So according to that, some energy will be stored. Next, so that the complete charge on the capacitor or the complete energy stored in the capacitor is going to be emptied. Total 0 volts will come across this capacitor. So with this magnetic field is going to be charged to the maximum energy charge. అయితే maximum energy charge అయినప్పుడు ఆ current flow అయిన direction plus and minus, but the produced EMF is back EMF and its direction will be this. అంటే ఏమవుతుంది, బ్యాక్ EMF దానికి వ్యతిరేకంగా ఉంటుంది కాబట్టి ఆ వోల్టేజ్ ఏం ఫామ్ చేస్తుంది అంటే ప్లస్ మైనస్ అనే వోల్టేజ్ ఫామ్ చేస్తుంది. నా whenever the capacitor is emptied and this energy is full, so what happens? Now this inductor will send current to this capacitor. ఈ capacitor కి current పంపిస్తుంది. So now what is going to happen? The capacitor is going to be charged in the reverse direction. అంతకు ముందు మైనస్ ఉన్నది ఇక్కడ ప్లస్ అవుతుంది, అండ్ దిస్ విల్ బికమ్ మైనస్. సో రివర్స్గా ఛార్జ్ అవటం మొదలు పెడుతుంది. అంతకుముందు ప్లస్ V వోల్ట్స్ ఛార్జ్ అయితే ఇప్పుడు మైనస్ V వోల్ట్స్ ఛార్జ్ అవుతుంది. సో ఈ రివర్స్ డైరెక్షన్లో మొత్తం టోటల్ magnetic field energy will be converted into electric field energy. So it will be charged fully to the negative volts. Negative volts ki charge ayyaka em avutadi? What happens? Again the current will now, ippudu idi fully charge ayipoyindi, idi empty ayipoyindi. Now my current will start flowing in this direction. My current will start flowing in this direction. So how I can explain this? ఇది చూడండి, నేను ఎలా ఎక్స్ప్లెయిన్ చేస్తాను దీన్ని అని అంటే, ఫస్ట్ ఆఫ్ ఆల్ ఇక్కడ ఫ్లో అయ్యే కరెంట్ ఇట్ విల్ చార్జ్ అప్ టు మ్యాక్సిమం కరెంట్. మ్యాగ్నెటిక్ ఫీల్డ్ ఈ కరెంట్ వరకు 0, 0.5, 1, 1.5, 2, 2.5, every time it's changing. So if it is a changing current, it will produce some back EMF. అదైతే నేర్చుకున్నాం. సో ఒక మ్యాక్సిమం వాల్యూకి వచ్చాక ఏమైందంటే యువర్ కెపాసిటర్ ఈస్ గోయింగ్ టు బి ఎంటీ అయిపోయిన తర్వాత ఏమవుతుంది, నా ఈ మ్యాగ్నెటిక్ ఫీల్డ్ తగ్గటం స్టార్ట్ అవుతుంది. అంతే కదా, ముందర స్టోర్ అయింది కదా, స్టోర్ అయింది ఏం చేస్తుంది, తగ్గటం స్టార్ట్ అవుతుంది. ఎక్కడి దాకా తగ్గుతుంది, 0 వరకు తగ్గుతుంది. సో కరెంట్ డైరెక్షన్ మాత్రం ఇదే, నెక్స్ట్ ఏమైంది, తగ్గటం స్టార్ట్ అయ్యాక ఇది నెగిటివ్ వేలో దీన్ని ఛార్జ్ చేయటం మొదలుపెట్టింది. అప్పుడు నెగిటివ్ వేలో డిశ్చార్జ్ అవుతుంది. సో నెగిటివ్ వేలో డిశ్చార్జ్ అయినప్పుడు దీన్ని ఛార్జ్ చేస్తుంది మళ్ళీ ప్లస్ మైనస్. సో బ్యాక్ ఈఎంఎఫ్ ఏమవుతుంది ఇక్కడ, మైనస్ ప్లస్. సో ఏమవుతుంది మళ్ళా, ఇక్కడి నుంచి మళ్ళా నెగిటివ్ వేలో చేయటం మొదలు. సో వాట్ ఐ గాట్ ఏ సైకిల్. తర్వాత మళ్ళీ అగైన్ ద ప్రాసెస్ విల్ బి రిపీటెడ్. మళ్ళీ ఇలా. సో దిస్ సర్క్యూట్, ట్యాంక్ సర్క్యూట్ ఈజ్ నథింగ్ బట్ ఏ LC ఆసిలేటర్ సర్క్యూట్. అంటే ఏమవుతుంది, ఈ రెండు హాఫ్ సైకిల్స్ ఇక్కడ కరెంట్ని ఇటు నుంచి ఇటు ఫ్లో అయిన కరెంట్, ఇటు నుంచి ఇటు ఫ్లో అయిన కరెంట్, ఇది చూపిస్తుంది. నెక్స్ట్ రివర్స్, ఇటు నుంచి ఇటు ఫ్లో అయిన కరెంట్, మళ్ళీ ఇటు నుంచి ఇటు ఫ్లో అయిన కరెంట్, ఇది చూపిస్తుంది. అగైన్ మళ్ళీ ఒరిజినల్కి వస్తుంది. మళ్ళీ ఇటు నుంచి ఫ్లో అయిన కరెంట్, ఇటు నుంచి ఫ్లో అయిన కరెంట్, దిస్ అండ్ దిస్. మళ్ళీ అగైన్ ఇటు నుంచి ఫ్లో అయిన కరెంట్, ఇటు నుంచి ఫ్లో అయిన కరెంట్, దిస్ అండ్ దిస్. సో యువర్ cycle will be repeated. In this way we will get the oscillations. So this is about the LC oscillator circuits.